So transistor is switched on when the base voltage, VBE is base voltage lah. So the base voltage is okay. So the base voltage must be at least greater than 2 volt. So name the type of transistor shown. So you see the arrow pointing downward. Okay, that means this one shows the current. So we know current start from positive to negative. So here P, here is N lah. Okay, here is P, here is N. So your transistor will be NPN. Okay, so transistor will be NPN. Okay, so type of transistor will be NPN. Okay, next B. Based on diagram 7.1, what is the potential difference across point X and point Z? So they ask you what is the potential difference across point X and point Z. That means from here up to here. Okay, see this one, X to Z is parallel to the battery. Okay, so you're parallel to the battery. So the voltage of the battery is 12 volt. That means from X to Z also will be 12 volt. Okay, because they are parallel. So 12 volt lah. Now, what is the total resistance between point X and point Z? Okay, that means total from here to here. So 27 plus with 3. Okay, so will be 30 kilo ohm. Okay, so 30 kilo ohm. Okay, next. Now, using the answer, calculate the potential difference between YZ. So they want you to calculate the potential difference between YZ. Okay, so calculate the potential difference between YZ. Now, so you see, so this one you can use the ratio method lah. You see, from X to Z, total resistance 30 kilo ohm. So we can say that 30 kilo ohm, okay, the voltage equals to 12 volt. Okay, that means from Y to Z, is only 3 kilo ohm. That means if 3 kilo ohm, so 3 kilo ohm. Okay, so the voltage will be 3 divided by 30 times with 12. Okay, so 3 divided by 10 is 3 and 30 is 10 now. So they get 1.2. Okay, so 1.2 volt. That means the voltage between Y to Z is 1.2 volt. Okay, so voltage between Y to Z is 1.2 volt. Okay, so 1.2 volt. Okay, so 1.2 volt. So this one answer for number 3 lah, B3 . So B3 answer will be 1.2 volt. Okay, 1.2 volt lah. Now, based on the answer in B3, state what happened to the lamp L. Explain your answer. Now, that means they ask what happened to the lamp L lah. Okay, you see so you know that the voltage here is 1.2 volt. So here is 1.2 volt. Now, if this one is 1.2 volt, Y and Z is parallel to your base, this is your emitter, and collector lah. So that means if this one is 1.2 volt, here also will be 1.2 volt. Okay, because they are parallel lah. Okay, now according to the question, they say the transistor will only be switched on when the base voltage must be at least greater than 2 volt. That means the base voltage must be at least greater than 2 volt. So the base voltage must be at least 2 volt or more. But now we can see that the base voltage is 1.2 lah, because this voltage is 1.2. So this voltage will affect your base voltage. So this one is 1.2. So your base also 1.2. So 1.2 is smaller than 2 volt. So that's why your bulb will not light up. Okay, or we call it transistor switch on lah. So that means your transistor won't be on. That means your bulb can never light up. Okay, that means the base voltage is very low lah. Okay, because that cannot pull the charges from emitter to base. That means charges from emitter cannot go to base because the base voltage is too low. It must be at least 2 volt to pull the electron lah. Okay, according to it depends on the transistor. So here must be here they say at least 2 volt. Okay, so this one is 1.2. So 1.2 is not powerful enough to pull the charges from emitter to base. So that's why they ask you, okay, state what happened to the lamp L. So that means the answer, it will not light up. Okay, so will not light up. Okay, so reason because base voltage, you can use VBE also can. Okay, so VBE smaller than 2 volt. Okay, or base voltage smaller than 2 volt lah. Okay, got 2 marks. Okay, now D, without adding any new component to diagram 7.1, what modification needed so that the opposite situation can be occur? That means without doing any changes, adding new component lah. So they ask you to modify the circuit so that the bulb can light up lah. Basically the bulb can light up. So now you see, in order for the bulb to light up, the base voltage down here must be at least minimum 2 volt. So now the problem is, what we have is, here is 1.2 volt. Okay, just now. Okay, so 1.2 volt just now we calculate, right? Okay, so what happened is here is 1.2 volt. So definitely cannot. But you see, right? If here is 1.2 volt, the total voltage here is 12 volt. Okay, that means on top here must be 10.8 volt lah. Okay, so 10.8 volt lah. So 10.8 plus 1.2, you get 12 volt. Right. So you can see that here the voltage is very high, 10.8, more than 2 volt. So what you must do is you just switch the 27 to go down, and then the 3 kilo ohm to go up. That means switch the position between R1, R2. Okay, so that your base voltage now is 10.8. 10.8 is greater than 2 volt already, then your minimum voltage. So that means when the base voltage is very high, there'll be base current, there'll be collector current. That means just say switch lah. Okay, that means R1 goes down, R2 goes up. Okay, so that means switch position between R1 and R2. Okay, next, an automatic fire alarm is needed to emit sound in case of a fire. Suggest 2 modifications that need to be made in diagram 7.1 by component with suitable component lah. So that means if you want to make a fire alarm, okay, so for fire alarm here lah, okay, that means the R1 you must put thermistor, and then the lamp you change with alarm. Okay, so so change R1 with thermistor. Okay, and then change lamp with alarm. Okay, so change lamp with alarm. Okay, 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 question number 22. Okay, a transistor based circuit is used as an automatic switch for light bulb P. Diagram 6.1 shows the circuit at night, and diagram 6.2 shows the same circuit during the day. Okay, so name the type of transistor used. So the arrow is going down, so this one will be NPN. Okay, now what is the effect of the light on the resistance of LDR? So what is the effect of light on resistance of LDR lah? So you can say lah, so when dark, resistance is high. Okay, or you can even say when bright, resistance is low lah. Either way is okay. Okay, now see. So based on diagram 6.1 and 6.2, compare the resistance of LDR. So this one is nighttime, this one is daytime. So nighttime, resistance LDR will be very high. Daytime, let's say LDR will be low lah. Okay, so comparison, that means 6.1 greater than 6.2. Okay, so diagram 6.1 greater than diagram 6.2 lah. Okay, now compare the base potential difference or VBE lah. Okay, so this one, right, actually you just refer to this. Okay, because this one is parallel to the base. That's right. This one. So if this one is 3 volt, base here also will be 3 volt because they are parallel. If here is 7 volt, here also will be 7 volt. Okay, because they are parallel. So that means diagram 6.2 greater than 6.1. Okay. So diagram 6.2 greater than 6.1. Now compare the brightness of the bulb. Now the brightness of the bulb. So here got bright, here no lah. So same lah. So brightness is same. Diagram 6.2 greater than 6.1 lah. Okay. Then they ask you to relate the base potential difference and the brightness. So you can see that the higher the base potential difference, the more the brightness. Okay. So the bigger VBE, so the brighter lah, brighter the bulb. Okay, so the bigger the VBE, the brighter the bulb. Okay. Okay, we look at E. Now diagram 6.3 shows the circuit which has been modified lah. Okay, so state the surrounding condition in which the bulb will light up. Okay, so the LDR is down here. Okay, so LDR. Okay, so that means dark lah. Okay, so when dark, the bulb will light up lah. So explain your answer. There's only one mark lah. Okay. Okay. So I can say there is base current, okay, flowing. Or we can say there is collector current flowing. Okay. We can even say the base voltage is high, not the VB. So the base emitter voltage is high. All this can. Okay. Okay. Now we look at the AC because transistor for the past few years has become very famous in your AC question now. Okay. So so we look at some of the questions that came out before. Okay, you look at number 12. Now, diagram 12.1 shows the symbol of the transistor. So name the type of transistor lah. So this one just name the type. So this one will be NPN. Okay, next. Diagram 12.2 shows 4 circuit JKLM containing detector, light dependent resistor, LDR, thermistor, dry cell, resistor R1, R2, transistor and above. So I required to determine the most suitable circuit that can be used to light up the bulb automatically lah. Only when it's dark. Okay. So you want to light up automatically when it's dark lah. Okay. So study the characteristics of the 4 circuits based on the following aspect lah. Okay. So type of detector. Okay, so this one actually you do your this one, you can do your table lah. But at the right for time being, I just write on the question here. So type of detector, there's only two detector lah, LDR and thermistor lah. So detector, that means because we want to detect the presence of light. So type of detector, you must say LDR lah. Okay. So to detect presence of light. Okay. So to detect presence of light. Okay. Now the position of the detector. So detector lah. So that means the position of your LDR, whether you put down or up. Okay. So you put down or up. So the LDR we must put down lah. So that means we must put at TU. So you can use the word TU. Okay. So position of the LDR is at TU. Down here lah. Okay, TU. Okay. So reason. Okay. So this one actually why we put that, you can say because of that there's base current flowing when dark, or there's collector current flowing when dark. Okay, so there is base current flowing when dark. Okay, or you can even say so that the base voltage is high when dark. So can lah. Okay, the base voltage is high when dark. Okay. Now the connection of the terminal of the dry cell. Okay, connection. So this is the arrow here. Okay, all these are NPN transistor. Okay, so this is your emitter, this is your base, this is your collector. Okay, now for an NPN transistor, emitter must be connected to negative. Emitter must be connected to negative lah. Okay, and then the base will be positive. Okay, okay. So okay, why? Because we want it to be, we want the So if you remember back, right, in the case of NPN, right, so when you look at the base and emitter, okay, so the emitter must be connected to, so the emitter, right, here must be connected to negative, the base must be connected to positive, okay, because actually this is like a diode, okay, so that means the emitter and base will be in forward bias, okay, so emitter and base must be forward bias, so that the charges from emitter, that means electron lah, the electron can go to base and then more will go to collector, okay, that means we want the emitter and base to be in the forward bias, so in order to be forward bias, the emitter must be in the negative terminal. If you put the emitter with the positive terminal, okay, the emitter here, right, so what happened, the electron instead of going up start to go down, okay, why? Because it is positive, okay, so it won't work lah, that means there's no electron going to your base, okay, there's no electron going to your base, so that means in order for it to be, we call it forward, because actually these two is actually a diode, okay, this one is a diode, base, sorry, this one is base and emitter is a diode actually, okay, because they have N-type and P-type semiconductor, so that means for the electron to go to base, to go to collector, the emitter must be connected to negative terminal, okay, so that means for this one, right, okay, how do we put it, okay, the answers for this, okay, so for this one, okay, the connection of the terminal of the dry cell, we just said, because down here, right, the emitter here, okay, so emitter connected to negative terminal of dry cell. Okay, so reason so that, okay, the base and emitter are in forward bias. Okay, so emitter connected to negative terminal of dry cell. So the connection of terminal of dry cell must be like this lah. Okay. Okay, so emitter connected to the negative terminal of the dry cell. Okay, so that the base emitter can be in forward bias. Okay, so base emitter is in forward bias. Okay, base emitter is in forward bias. Okay. Okay, now the position of the bulb. Okay. So the bulb we must put at the collector here. Okay, you can say between V and W lah. Okay, between V and W because you already put alphabet here. Okay, between V and W not here. Okay, so position of the bulb we just say between V and W. Okay, so reason the bulb lights up when there is collector current. Okay, so the bulb lights up when there's collector current. Okay, so that the bulb lights up when collector current, when there is collector current. Okay. Because when there is collector current here, then only the bulb lights up. No collector current, there's no, the bulb will not light up. Okay, so if there's collector current, the bulb will light up. When there's no collector current, the bulb will not light up. Okay. So try not to use this one, the bulb light up when it's dark. Okay. Yes, we put the bulb there because we want the bulb to light up when it's dark lah. But the thing is, it's already in the question lah. Okay. Try not to use the statement in the question as your reason lah. Okay. That means you try to use other words. That means the bulb lights up when there's collector current. Okay. Because they already put there, we want the bulb to light up when it's dark. So when you say, okay, we put the bulb there so that it lights up when dark, we are actually repeating what is the question saying lah. Okay. Okay. So that's why try to use other reason. Okay. So then you choose the best one. The best one will be this one. This one. Yeah. Okay. Number, as you see, diagram 12.3 shows a circuit which is used to amplify the current. Okay. Amplify the current. Okay. So state whether there is reading in a micrometer and milliammeter when switch S1 on and S2 is off. Okay. That means when you on this one, right? But you off this one. So when you off this one, that means there's no base. Okay, always remember, no base current, no collector current. Okay, no base, no collector. Okay, so no, both also don't have. So I just say no lah. This one don't have, this one also don't have. Because there must be charges going to base, then only going to collector. So S2 switch off. Okay, S2. S2 switch off, S2. S1 switch off, switch off. I think this one is wrong. Okay, this one you put S1. Okay, change. S1 switch on. Okay, S2 switch on. Okay, so S1 switch on, S2 switch on. Both must switch on. So still whether there's reading ammeter and millimeter, so yes. Okay. Okay, this one change. So it's wrong. S1 switch on, S2 switch on. Okay, yeah. Now, so explain how the circuit function as a current amplified when the rheostat adjusted and both switches are switched on. Okay, so when both switches are on. Okay, So explain how the circuit functions as a current amplifier. Okay. So what happens is when you change your resistor, right? Okay, when you change your resistor, what happens? This one will change your base current. Okay, so this one will produce a small changes in base current. Okay, that means when you adjust your resistor, right? So this one will produce small changes in your base current. So because of that, what happened? A bigger changes in collector current will occur lah. Okay, this is the amplifier circuit. Okay, that means okay. So let's say right, they have 10 electron, right? Okay. So let's say the resistance is high lah. So maybe 2 electron can go here. Okay. Now 8 electron is going up. Let's say lah, 2 goes here, 8 goes here. Okay. So let's say now you reduce the resistance of your start. So when you reduce, what happened? Now maybe more electron from the emitter can go to base. So maybe 20 can go here. So out of 20, maybe 4 will go to base, 16 will go to collector. That means what happened? The small changes in base produce big changes in collector lah. Okay. So so explain how the circuit function as a current amplifier. Okay. So sir, when you start, okay, it's adjusted. This causes small changes in base current. Okay, so when you start adjusted, this causes small changes in base current. So 1 mark. So because of that, big changes in collector current. Will occur. Okay, so when you start adjusted, this causes small changes in your base current now. Okay, that means okay, when you adjust the rheostat here, that means what happened? Okay, maybe the number of electron changes from emitter to base. So small changes from emitter to base produce big changes in collector lah. Okay, so rheostat adjusted, this causes small changes. So the keyword here is this one lah. When you talk about amplifier, must have the small changes. Okay, in base current. So this one produce big changes in collector current. Okay, now D. Based on diagram 12.3, the reading of microammeter is 10 microampere and the reading of milliammeter is 1 milliampere. So calculate the current amplification by using the formula I equals to IC over IB. Okay, this one you just use the formula lah. So I equals to IC over IB. So now the thing is, what happened? The base current and the collector current has different unit. This is milliampere, this is microampere. Micro is for this one for base, this one is collector. Milliammeter is collector, microammeter is base current. So the best thing is change everything to ampere lah. Okay, so collector current is milliampere. So milli is 1 times 10 to the power of negative 3. Okay. Milli is divide with 1000. That means 1 times 10 to the power 3 lah. Okay, micro means is divide with 10 to the power 6. So micro will be okay, so 10 microampere. So micro is 10 to the power of negative 6. Okay, 10 to the power negative 6 lah. Okay, so when you simplify, you get it's negative 553. Actually, get 100 ampere. Say 100. Sorry, there's no unit, huh? There's no unit because this one is ampere. Down here also ampere. Okay, so the answer will be 100. Okay, answer will be 100. Because it's 10 to the power 1, right? So to the power 1 times to the power negative 6, you get negative 5. So negative 5 we bring up becomes 10 to the power 5 lah. Okay, so it becomes 10 to the power of negative 3 times 10 to the power of 5. Okay, because negative 5 goes up becomes 5. Okay, so 5 minus 3 give you 2 lah. Okay, if we put it in standard form, okay, if we put in 10 to the power 2 lah, 400 ampere. Okay. Okay, next, what is the emitter current? So what is the emitter current? Okay, so emitter current, so we know, right, IE equals to IB, IB plus IC. Okay, so your base current is 10 times 10 to the power negative 6, because in micro, right? And then your collector current is 1 times 10 to the power of negative 3. Okay. And to the power of 5 plus 10 to the power of negative 3. Okay, so answer will be 1.01 times 10 to the power of negative 3 ampere. Okay, because already convert to ampere. So because already convert to ampere. Okay. Okay, we look at another one more example. That's also passive question. Okay, this one we haven't learned yet. Okay, so we just leave it 12A lah. Okay, 12B. Now diagram 12.2 shows an amplifier circuit lah. So explain how the circuit function as an amplifier, 4 marks. Okay, so 4 marks, you must 4 points lah. Okay, so this one actually okay, so the points I give you in the notes. Okay, so 4 points, right? So you just see when a person speaks in the microphone, so sound wave are converted into alternating current. Okay, you can see when microphone detects sound, okay, so the sound wave converted into alternating current. Okay, doesn't mean must be we speaking. Okay, so just say so microphone detects sound. Okay, so this sound will be converted into alternating current. Why? Because when we talk with the different loudness. We talk with different loudness, so that means we fluctuate up and down, up and down, up and down. Okay, because our tone won't be the same. Okay, so the next one will be this causes a small change in the base current. Okay, this one will cause, so this one is 1 mark lah. Okay, and then this one cause a small change in your base current, which will cause a big changes in your collector current. Okay, and then the earphone receiving a larger current converts into loud sound lah. Okay, see so this one causing loud sound to be produced at the earphone also can. Okay, so after say okay, this causes a big change in collector current, so this one produces or loud sound Okay, comes out from the earphone lah. Okay, not sound comes out from the earphone. Okay, okay, you can say sound with higher amplitude. Okay, sound with higher amplitude is for this lah. Okay. Okay, 4 marks. Okay, now diagram 12.3 shows an incomplete fire alarm system. Circuit. Table 12 shows 4 sets of components. So this is an incomplete circuit. So basically, they give you component. So you're required to determine the most suitable set of components that can cause a fire alarm system to function. So you want to create a fire alarm system. Okay. So study the electronic component utility, right? Okay. So now, so this one actually same lah. You have your characteristic and reason. So it's much more easier because they use the word terminal. Yeah. So first we look at the terminal. So terminal JK lah. So what you must put lah? So you must say terminal JK must have thermistor. Okay. So terminal JK have thermistor. That means when you write, right? Okay, your answer you can give in a table form. So the first column here will be characteristic. Then here will be reason. Okay. So okay. So characteristic terminal JK. Let's say thermistor lah. Okay, thermistor. Okay. So reason you can say to detect presence of heat. Okay, to detect presence of heat. Okay. Next, terminal LM. This one, right? Okay, this usually, right, if you see most of your transistor circuit, at the base circuit here, they'll put a resistor. Okay. Now, why? Because the function of a resistor basically is to limit your current. But this one they put at the base. Why? They want to limit the base current. Okay, the base current, what happened? If the base current is too big, it actually can spoil your transistor. Okay, so it can spoil a transistor if the base current is very big. Okay, so if the base current is very big, it can spoil a transistor. So the function we put a resistor here is to limit the base current. Okay, so that the base current is not very high. Okay, so that means here, okay, terminal LM. So what we must put is we must put a resistor. So put the resistor. Okay. So reason to limit base current. Okay, must have the word base current, not current only, to limit the base current because we put it at the base. Okay, we put it at the base. Okay. Next, terminal NO. Okay, so terminal NO here lah on top here. So we put alarm. Okay, alarm. So reason to emit sound. When there is fire. Okay, or when temperature is high. Okay, so to emit sound when there's fire or when there's temperature is high lah. Okay, and then lastly terminal PQ. Okay, terminal PQ. So this one you look at your transistor lah. So this is a N, E, N. So this is your emitter, base, collector. So for NPN here must be negative, here must be positive. Okay, so the emitter must be negative so that your base and your emitter can be forward biased. So terminal PQ, they put there cell 1, cell 2. Okay, okay. So cell 2 means down is negative lah. So just put cell 2. Okay. Okay, cell 2 lah. So reason so that the base and emitter are in forward bias. Okay, so that the base and emitter in forward bias. Okay, so these are example of question. Okay, okay, that came out for SPM lah. Okay, I think this one was 2018. Okay, 2018. 2019 came out also. Okay, this one is section C. What I gave you is section C. All these section C lah. Last year was section B. Okay, so it's almost similar lah. Okay, so it's almost similar. Okay, now, so basically, right, for transistor, right, okay, basically you only have LDR and inter application, right, LDR and thermistor lah. So usually, right, for LDR, right, what you want is, example, you want the bulb to light up automatically when dark. Okay, we want the bulb to light up automatically when dark. That means we want the transistors to be switched on when dark. That means when dark on, when bright off lah, when bright is off. So the LDR must always be down. Okay, the LDR must always be down lah. Now how to remember? Very simple, because L, right, LDR, right, so you just remember L as low lah. Okay, low. Okay, that means the LDR will be at the lower position. Okay, this way to remember lah. So because usually for LDR, normally, right, we want it to function when dark. When light, when bright, we don't want it to be on. That's basically, okay, if okay, the question is like that lah. We want it to be on when dark. So the position is down here, low, low. So we put, okay, lower position lah. Okay. Now, whereas for thermistor, usually what we want is when it's hot or when the temperature is high, we want the transistor to be switched on. Okay. So thermistor, usually we put it on top. Okay. So thermistor, usually we put it on top because we want it to be on when hot, or we want it to be on when there's an increase in temperature. Okay. So the thing, okay, is, okay, thermistor, right, is opposite of LDR lah. LDR we when dark, okay, not when bright, we need to be on. Usually when dark, we need to be on. Whereas for thermistor, when hot, we want to be on. So thermistor always we place on top here lah. So very easy to remember. You see, you start with T, right? So just remember T as top. Okay. So thermistor always you put at the top here. Okay. LDR usually you put at lower position here. So you just, okay, remember according to their first alphabet lah. So thermistor top, so you put at the top. LDR, okay, we put it down here. Okay. So this how I remember lah. Okay. Same lah. If thermistor, sometimes the one that came out before in SPM, they ask how to switch on aircon automatically when the temperature is very high, or how to switch on a fan automatically when it's hot. So same thing lah. Okay, you put the thermistor here, here you put the fan, or you put an aircon. Okay. Okay. So I think that's all for transistor.